Welcome back, everybody. Patrick here. Moving on to another question. We have to determine the equation of the tangent to f of x equals square root of x plus 2 at an x value of -1. So before getting into the math, let's show what's going on in a diagram quickly. So if we graph this function, square root of x plus 2, that's like the parent function square root of x shifted by 2 to the left. So it's going to start here at -2 and 0, and it's going to look something like that. And what this question is asking us for is at an x value of -1, which is here on the function, what's the equation of that tangent line going to be right there? Right? So that line is going to have the form y equals mx plus b. So the first step is let's find what the slope m is going to be. And we know that the slope, tangent slope, of any function when x is equal to a is equal to what? It's the limit as h goes to 0 of f of a plus h minus f of a all over h. So what we have to do is we have to plug a plus h and a into the function that we are given. Let's find a general expression first for any x value a, and then we'll plug in our specific x value of -1. So we got the limit as h goes to 0, f of a plus h, if we plug in a plus h for x, we'll have the square root of a plus h plus 2 minus f of a, if we plug in a for x, we'll have the square root of a plus 2 here. And this is going to be all over h. So what we have to do is we have to try to get rid of this h here in the denominator, so we're going to have to rationalize this. So we have to rationalize the numerator. Notice how it's a 2-term numerator. So to rationalize it, we got to multiply it by its conjugate. And its conjugate is just going to be the radicals kept the same, but the sign in the middle switches. And we got to put that conjugate in the denominator as well. Square root of a plus h plus 2 plus the square root of a plus 2. So now, when we multiply this 2-term expression by its conjugate, it's going to be a difference of squares, so we only have to multiply the n terms by each other. So we would have square root of a plus h plus 2 times the square root of a plus h plus 2, which would just be a plus h plus 2, minus square root of a plus 2 times the square root of a plus 2 is just a plus 2. And then this is going to be all over h. And then this term, let's keep separately. So we got the square root of a plus h plus 2 plus the square root of a plus 2. So this h and this don't simplify into anything nice, so let's just keep them separate in the denominator. And then notice when we distribute the negative inside the bracket, the a's will cancel out and the 2's will cancel out, because we'll have minus a minus 2, and we'll just be left with an h in the numerator. So your next line would be the same expression, except we just have h left in the numerator. Denominator stays the same. And now notice h's cancel out and we're left with 1 up top. And now we can plug in an h value of 0. So this h here would go to 0. So we would have the square root of a plus 2 plus the square root of a plus 2. Those are like terms, so we just have to add the coefficients that are in front, 1 and 1. So our final answer is 1 over 2 square root of a plus 2. Right? So this here is the general expression for the slope of the tangent at an x value of a. And now we need the slope of the tangent at a specific x value -1, so we just plug in -1 for a. So -1 plus 2 is 1, square root of 1 is 1, So we're just left with 1 over 2. So when x equals -1, the slope of the tangent is equal to 1/2. Right? So step 1 is complete. Slope of the tangent, the slope of this line here, is going to be 1/2. And you can use this expression to find the slope of the tangent at any x value on the function. So if we wanted to find the slope of the tangent at an x value of 3, for example, here, we would just plug in 3 for a, and we would get that slope. But we're only working with an x value -1, so that's all we plug in. So the slope is going to be 1/2. So step 2 now, let's put a line here. So I'll do step 2 over here. So step 2 is we have to solve for the b value. And the way we can do that is we got y equals 1/2 x plus b, right? The slope is 1/2. And all we have to do is we have to plug in the x value and the y value at that point. Well, we know the x value is -1. The y value we don't know, but we can find the y value by plugging in x equals -1 into the function. -1 plus 2 is 1. Square root of 1 is just 1. Right? So y is 1, and then x is -1 plus b. So we got 1 equals -1/2 plus b. Bring the -1/2 over. 1 plus 1/2 gives us 3 over 2. So our final equation for this line here is y equals 1/2 x plus 3 over 2, that b value. Right, so 2 steps. We have to find the slope of the tangent, and then we have to solve for the b value using the coordinate. Sometimes they'll give you the full coordinate on the function, or sometimes they'll just give you the x value, and then you have to find the y value manually by plugging it into the function, but it's not a big deal. Right? Another way you could have found the slope of the tangent here is you could have plugged in this x value -1 for a right away, and then did the difference quotient algebra, and then instead of getting this expression, you should get a slope of 1/2 right away. It should just be a number because you're looking at a specific a value now, or a specific x value. But I prefer to just get a general expression first and then plug in that actual x value that you are working with. But either way, that's your final answer. Y equals 1/2 x plus 3 over 2.